Okay, we've been talking about domain and range for a few days now, but this whole lesson is really practicing domain and range given a graph or given an equation. So can you guys copy that down and pause if you have to? But the domain is going to be the set of all x values that also have a y value, and the range is the set of all y values that also have an x value. So where is there a point? That's how we're going to describe the domain. So the domain are going to be the x values where there's a point, and the range will be talking about the y values where there's a point. So here are the instructions for this top box. And this should be review, these 6 questions. Using interval notation, that's the new intervals, identify the domain and range of each graphed function below. So domain's going to be the x's. So you think, where is the smallest x value that has a point? Okay, there's no graph here. So the graph begins when x is -4. But is there a point or a hole? It's an open circle. So the -4 is not going to be included. So we're going to have a parenthesis for -4 and then follow the graph. Down, up, down. Now this arrow means that the graph does not stop at a certain point. This arrow means it goes to infinity. So the x's, it's going to go to x equals positive infinity. It's just going to keep going. Now, infinity can never be included, so anytime you have an infinity, it'll always be a parenthesis. Okay. Now let's talk about the range. Now, I know some of you guys want to start here to talk about the range, but we have to change the way we think about it. The range, we have to start with the smallest y value. So it has to go least to greatest. So we can't start at 5. That's actually going to be the greatest y value we see. So come to the bottom of the graph, and we have this vertex point, but then we have this arrow. Now this arrow, what does that mean? It means that this is going down forever to -infinity. So this range, the lowest y value is -infinity. Did you hear that? I had to cough. Sorry. So now we're coming up, and what's our highest y value? We have a point here at 5. Is that 5 included or not included? It's going to be not included, so we're going to have a parenthesis for the whole. All right, let's do another one. Domain, these are the x values. Where does the x value begin? What's the smallest x value? Arrow. Anytime there's an arrow, we're going to say that's -infinity. And then it goes to 1. But what happens? There's a hole at 1. So we have to stop our interval at 1 and then unite it with another interval going from 1 to, sorry, it'll adjust. Will it? There it goes. Okay, the lights came off. The lights don't come off, the lights turned off. Can you guys see that okay? Okay, why? We can't include the 1. So we go from -infinity to 1, and then there's a hole, and then from 1 to positive infinity, because the arrows, that's what they mean. Now, what about the range? Is it going to be the same? Let's think about this. We're down here at -infinity. Do you agree? And we're going up, but do we have to skip this 1? Or is there a point also here at 1? Do you guys see that point? So is 1 included in the range? Yeah, it is. So -infinity to what? Is there another arrow here? So that's going to go to positive infinity, and there were no other holes in the graph. Okay, domain, x, where do we start? Arrow, so if there's an arrow here, and we wrote down -infinity. So there's an arrow on the left, so we're going to write down -infinity. Now let's think about this. Is there a x value for every y value? So we have x, 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 and then I see a hole. But is that hole filled in somewhere else? Yeah, it's right here. Okay. So there is an x value for 0.99999. Is there an x value for 1? Yep, it's right here. Is there an x value for 1.000001? Yeah, right here. And then it picks up and keeps going to an arrow. So guess what? The domain is from negative infinity to positive infinity, which means all x's, all real x values. So even though this funny thing happens, there was actually an x value defined for every y value. Now what about the range? Go to the bottom of the graph, and is there anything down here? And is there an arrow down here? No. So where does this start? Kind of just go up, work your way up, and I see the y value, it begins at -3. Open or closed? Closed. Just kidding. Open. Just making sure you're paying attention. Okay, now is every y value accounted for? Well, this, what is that? Oh, those are like eyelashes. Okay, is every y value accounted for? Well, doesn't that arrow go all the way up to infinity? I'll just keep going, going, going. So this line all by itself takes care of every y value because it just keeps going and going and going and going, okay? But then we also have this piece going up here. But all these y values that are kind of skipped here are taken care of by this line. So this goes to positive infinity. Domain and range 2.0. All right, let's look at this. Domain, x values. What do we see? An arrow. Awesome. Now, is every x value included, or is there like a jump? Here we go. Here and here, -1, is this point. Now that point was defined somewhere else over here, but do you see an x value defined anywhere here at -1? Nope. So we need to jump, we need to skip over -1. So we end, the first piece ends at -1, and then that's this piece on the left here. See how that ends at -1? Now what about this piece? This goes from x equals -1 to x equals 5, right? Okay, now let's talk about the domain. The domain, nope, we just talked about the domain. My apologies. The range, what's the smallest y value we see? Are there any arrows down here? No. Do you see this point as the smallest y value? Now is that open or closed? Uh-oh, I messed up. I messed something. I said, do you guys see an arrow down here? And you said, no, Miss Keener. But there's actually, do you see this arrow? What? So is that going to keep going forever? Forever, forever, ever? So our range is actually -infinity. And then do we have a top of a maximum y value? Careful, I'm going to check my arrows. Any arrows here tricking us? No. So what's the biggest y value we see? Oh, what do you think there? 3.5? Can we agree on that? 3.5? Okay. All right. Number 5, domain. Leftmost y value is -5. I'm sorry, x value. I'm zoning out. I need to focus. Are you focusing? X value. Domain is x value. And that's going to be an open parenthesis because it's an open circle. And that's going to go, what happened, is this defined here? Yes, at -1. And then it jumps down here. And then it goes with an arrow. So if it's an arrow, then we put infinity. Okay. Range. No arrows here. So I don't have to worry about being tricked like I did on the previous one. And this arrow is going up. But what's our lowest x value we see? This point, do you agree now? Okay. We've been using only parentheses because we've been seeing a lot of holes. But do you guys agree this is an actual point? So we need to include this -3 in the range. So we're going to put our first square bracket on the paper because that point is included. And then this arrow is going to where? Positive infinity. You agree? Okay. So that's going to be like that. All right, number 6. Here we go. Domain. Is this an arrow? Yes, it is. So the domain is negative infinity. This looks like, I'm going to write small. Negative infinity to, okay, we go up, 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 down, down, down. This point then goes to this hole. And then we go down here. And what the heck is this thing? Okay, this is something called an asymptote. I'm not cussing. Asymptote. We'll practice saying that. An asymptote is a dotted vertical line that means there's nothing there. There's no graph, there's no number, it's undefined. So this asymptote is at 2, so we have to jump over the 2, just like we did with a hole. So we go to 2, but not equal to, and we jump on the other side, and now we're going up to 4. Is 4 filled in anywhere else? No. So we have to jump over 4. And then 4 goes, after 4, we go to infinity. Well, that was fun. Now, what about the range? The smallest y value. Do we have arrows going down? Okay. We have arrows going down. And then the largest y value. Do we have an arrow going in the up direction? Yeah. So the range will be all the y values. Well, that really kicked domain and range like to a new level, didn't it? I hope you had fun doing that. Okay. Analytically. Analytically means not with a graph. It means based on your knowledge of the graph, we're just going to look at the equations, okay? But before we get into answering what's the domain, let's sketch a general graph. So this was kind of what your quiz was about, right? So you should be able to sketch a general graph of the constant function would just be a horizontal line at C. I'm going to do all the graphs first. This is a linear function. So a linear function, ax plus b, and we don't know what ax plus b is, but that's one with a positive slope. And the absolute value looks like that. And this x value here would be b according to the formula given, and the y value would be c because you would move it left or right, up or down according to b or c. And then a quadratic we know looks like a parabola. All right, there's my general graphs. Okay, what's the domain of this constant function? Well, what's the left answer is an arrow, so we're going from negative infinity to positive infinity. What's the domain of a linear? Also negative infinity to positive infinity. What about absolute value? Does it have a left arrow and an arrow going right? So the domain is negative infinity to positive infinity. And then the quadratic, this arrow goes to the left and this arrow goes to the right. So that's also negative infinity to positive infinity. And you go, wow. Okay, why does this have a domain? It's because these are called functions. So say functions. Functions. The domain are all x values, and that's one thing that makes it a function. Okay, let's turn the page. Page 2. Oh, I'm running out of time, but that's okay. Let's see. I don't know if I can answer all these. Given below are 3 of the graphs, 3 different, I can't read. Given below the graphs of 3 different functions that we will investigate analytically, refer to them as you complete the table below. Identify the domain of each function. Look out for another video or maybe just a page of notes to copy this page, probably from a picture. Okay, thanks.